Hello everybody, this is more of an algebra lesson, but we're going to incorporate it into a geometry lesson. I can add radicals by reducing first and combining common radicands. So you should already know how to reduce radicals. I have a separate lesson on that. This just kind of builds on that. Basically, whenever I'm adding radicals, I want to reduce first so that they have the same radicands. Then I add my coefficients. I keep my radicand. Radicand meaning the number inside the radical. If they don't have the same number inside the radical, then we can't add them. So let's write out our perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And we're going to refer to those for each problem. That didn't work. Okay. So, number one, I want to reduce each radical. So I've got radical 25, radical 2, radical 25, radical 2. You can use the calculator if you need to come up with those values. You're looking for the largest perfect square that goes into 50. It's not 49, it's not 36, it's 25. Square root of 25 is 5. Square root of 25 is 5. Now that they have the same radicand, 5 rad 2 and 5 rad 2, I add my coefficients. 5 and 5 is 10. I keep my radicand, and that's my answer. Reduce first, add last. Let's jump to something like number 4. Get my perfect squares back. I want to reduce radical 45 because right now they don't have the same radicand. So again, I can use my calculator trick. If I go to y equals, I type in the number divided by x. I'm looking in my y column for the number that's on my perfect square list. So I see 9. So 9 is my perfect square. 9 times 5. Radical 125. I can do the same thing if I want. 125 divided by x. Just make it bigger. View, show large display. So if I go to my table, I'm looking in my table for a number that's on my list. That was too big. I see 125, no. 62.5, no. 25, yes. 25 and 5. Take the square root of my perfect square. Square root of 9 is 3. Bring down the radical. Square root of 25 is 5. Bring down the radical. 3 rad 5 and 5 rad 5. I combine my coefficients. 8. I keep my radicand, rad 5. Again, this is contingent on you knowing how to reduce radicals. So if you don't know how to reduce radicals, then take a look at that first. If there's something in front, we ignore it for now. I reduce each of these. I reduce radical 200 and I reduce radical 18. Use the calculator trick if you need to. I'm not going to pull it up again. The largest perfect square that goes into 200 is 100 times 2. The largest perfect square that goes into 18 is 9 times 2. Now these 2's, I'm just going to throw them in front. The square root of 100 is 10. Radical 2 comes down. The square root of 9 is 3. Radical 2 comes down. And then I take that outside number and I multiply it by my outside number. So if I had a 2 in front of the whole thing, I multiply the 2 and the 10 and get 20. Radical 2, the 2 and the 3 is 6. Radical 2. Now that I have a common radicand, I combine my coefficients, 26, radical 2. So if there's something in front of the radical, you just ignore it and multiply it at the end. And finally, if I have something like let's do something like this, number 9. Again, I'm going to reduce each of my radicals. So I'm going to reduce radical 80, and I'm going to reduce radical 45. Ignore the 4. Ignore the 2 for now. 80 would be 16 and 5. 45 would be 9 and 5. Square root of 16 is 4. Radical 5. Square root of 9 is 3. Radical 5. Multiply my outsides. 16 rad 5 plus 6 rad 5 plus 12. Now when I go to combine my like terms, 16 rad 5 and 6 rad 5 is 22 rad 5 plus 12. I can't combine that. It's not a like term. So my answer would be 22 rad 5 plus 12. You combine what combines, you don't what doesn't. Which I guess brings us to our final problem we're going to go over together. Number 10. If I want to add these, I need to reduce first to get a common radicand. I also have to reduce because if it says simplest radical form, I need it in simplest radical form. 25 and 3, 4 and 6, bring down the 3, bring down the 4. That plus 8 kind of got squeezed out there. I'm just going to put it in the back. Square root of 25 is 5. Square root of 4 is 2. Multiply my outsides, so I have 20 radical 3 plus 6 radical 6 plus 8. Now that I reduced everything, what can I combine? Nothing. Radical 3 is not the same as radical 6. This one doesn't have a radical. So if I can't combine them, I can't combine them, and that's my answer. Again, this is an algebra lesson, but it's about to be combined into a geometry lesson, into your perimeter on the grid lesson. To add radicals, we want to reduce first. Once I reduce, I combine the ones that have the same radicand. 20 rad 2 and 6 rad 2 is 26 rad 2. If they don't combine, whether it's a different radicand or an integer, then I just don't combine them, and I leave the answer as plus. That's it. Goodbye.